Today we're going to cover 13.2, which is angles and the unit circle. So this is the second part of it. So if you notice in the upper left-hand corner it says vocabulary, the unit circle. It is a circle with radius equal to 1 unit. So unit circle makes sense. The radius is 1 unit. So the unit circle is a circle with radius equal to 1 unit. All right, now I want you to watch me real carefully when I draw this symbol up here, okay? So I just want to have to draw it once. Can everybody eyes on the board? Watch this. It's going to look like the letter O, but then you're going to loop and stop. This is a Greek letter called theta. Okay, it's a Greek letter, and we say theta, T-H-E-T-A. The Greeks are credited with the discovery and use of trigonometry. So we use a lot of Greek letters. We're going to use alpha and beta, but theta is just the variable we use for an angle. Okay? It's the variable we're going to use for an angle. All right, so what I want you to do now is this is our unit circle. So if you notice, this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And the point 0, -1. Again, everywhere I draw a radius, it's 1 unit. But when I go left, it goes to on the coordinate grid to -1. So what I want you to do is let's pick a point, x, y, on the circle. Okay, can you draw that? And then what I want you to do is I want you to go to the origin, and we're going to draw a radius. And since this is a unit circle, so you need to know some geometry, this is still a radius. So it has a length of 1 because it's a unit circle. Now what I want you to do is I want you to drop a perpendicular segment, and we're going to create a right triangle. Maybe mine doesn't look so straight now. I'm going to try to make yours straight down so it forms a right triangle. And we're going to call the angle from the hypotenuse, or the radius, to the x-axis. We're going to label that angle theta. Okay? Now, in my triangle, if I'm at the point xy, do you understand that I went to the right x units and I went up y units? So I'm labeling the triangle. So I have the hypotenuse is 1 because the hypotenuse is the radius of the circle. And then I stopped it going right x and up y. So you have to understand the basics of a point. All right, now we're going to make a beautiful connection to SOHCAHTOA. You guys remember SOHCAHTOA? That's the sine of an angle. We're going to call it theta. Sine theta is the opposite side over the hypotenuse. And I want you to look at the triangle we drew with the theta in it. If I use SOHCAHTOA for sine, what would sine theta be in this triangle? Grace? Y over 1. Well, what's y over 1? Just y. This is going to be important, okay? It's going to be super important. Now let's do the that's cosine, and you always have to have an angle because you can't say, I'll see students who put sin or cos equals 1 over 2. And I'm like, that makes no sense because you're not telling me what angle am I coming from. You can't be the opposite of nothing and get 1 over 2. So you always have to have an angle. So, and for us, for now, we're going to use theta. So cosine theta is adjacent over hypotenuse. Is this coming back to you guys? Do you remember this from geometry? SOHCAHTOA. All right, so according to this diagram of my triangle, what would cosine theta be? X over over 1, which is x. And then TOA stands for tangent, is opposite over adjacent. So according to this diagram, if tangent of an angle is the opposite side of that angle over the adjacent, what would that be in the triangle? Y over x. But guess what? Look back at what we figured out from So and Ka. Sine theta is y. X is cosine theta. Correct? Is that correct? So couldn't I rewrite this as tangent theta equals sine theta over cosine theta? This third one we're not going to need right now, but we are going to use it later in the chapter. So let me pause and I want you to look at what you wrote down. Okay, a unit circle is a circle with radius of 1 unit. Theta is the variable, it's a Greek letter, theta. We're going to use this Greek letter to be the variable for angles. So we looked at a unit circle where the radius is 1. So I know this is going to take a little bit of time to get used to. When I say unit circle, you need to remember the radius is 1 everywhere and anywhere I draw it. We drew a point, xy, anywhere on the circle, and if I make theta, this angle between the hypotenuse or radius with the positive x-axis, that's my angle theta. I went right x and up y. I can do SOHCAHTOA, and the sine of theta was y over 1, or just y. Cosine theta was x over 1, which simplifies to x. Tangent theta is y over x. But with this newfound information, that's sine theta over cosine theta. Now, if sine theta is y and cosine theta is x, every ordered pair on the unit circle, x comma y, is equal to cosine theta comma sine theta. This is going to be really important. And I'm trying to go nice and slowly here and give you time to look and think. Does that make sense? If you look at the picture, the x-coordinate is cosine theta. It's an equivalent way to name it. And the y-coordinate is equal to sine of that angle. All right, let's look at the box. Suppose an angle in standard position has measure theta. The cosine of theta, and we abbreviate cosine COS. You should have learned that in geometry. And we don't say cos, we say cosine, even though we write COS. So cosine is the x-coordinate, and the sine theta, which we abbreviate SIN, we don't say sin, we say sine, theta, is the y-coordinate. So if you look at this dot up here, what are the coordinates of this point P? Daria? Yeah, it's 0, 1. Now watch this. The x-coordinate is cosine of your angle rotation. Well, what is the angle rotation up to P? How many degrees is that? 90 degrees. So watch this. Cosine of 90 degrees is equal to the x-coordinate. So that's 0. My y-coordinate equals sine of that angle of rotation. Well, this angle of rotation is 90, it's still 90. So the sine of 90 degrees equals 1. All right, so go ahead and turn the page when you're ready. And just on what we did, we're going to look at example 1. It says, what are the cosine, theta, and sine theta? We're going to do this 3 times. If theta is 90 degrees, you have to figure out where's a 90 degree rotation. It's right here. So we just did this one, right? So the cosine of 90 degrees is the x-coordinate, and the sine of 90 degrees is the y-coordinate. Now you can either go back to drawing the circle with the triangle to remember this, but if you want kind of it's not mathematical at all, but if you want to remember which is x and which is y, think of c comes before s. So cosine is always the first one, sine is always the second one. Okay, not mathematical at all. But here's what I want you to do. Try B and C. You're going to have to make a sketch, so it's a really good thing we practiced yesterday, sketching angles. Figure out where negative 180 is. Then the cosine of negative 180 will be the x-coordinate there. And then the y-coordinate will be the sine of negative 180. Alright, so negative 180 degrees. So here's the positive x-axis. Here's negative 180. So here's the ordered pairs. Does that make sense? How you do negative 180. If you have a negative angle, I put it in a parenthesis. If you didn't, just gently put a parenthesis around it. Cosine is the x-coordinate. And don't lose your angle. So the sine of negative 180 is 0. This is really nice. Yeah.
So, I got that. Then for the first one, point is 0, 1.
Yeah.
Oh, never mind.
Because I did cosine first.
Yeah, I just looked at it.
Okay. All right, 270. So here's 270. So it's this one. So cosine 270 degrees is 0. The sine of 270 degrees is negative 1. All right, any questions on that? So cosine of an angle is the x-coordinate. Sine of the angle is the y-coordinate. All right, I passed out this little sheet of paper, and this is what you can use on the next quiz and the test. This is the only thing. But we're going to start off with what you learned in geometry, and then we're going to see how I got to what I did on that slip of paper, okay? So in a 45-45 right triangle, you learned that the two sides are equal and the hypotenuse is x radical 2. If you would like me to go through where that radical 2 comes from, I can do that during office hours. Or when you have time to work on homework, I would be happy to do that. But I'm assuming from geometry, you learned where that came from. All right, in a 30-60 right triangle, across from 30 is always the shortest side. Okay, across from the 30 is always the shortest. The hypotenuse is across from the right angle, and that makes 60 the one left over. Across from 30 is x. The hypotenuse is 2x, and across from 60 is x radical 3. Okay, this is from geometry. This is what you learned. Now I'm going to show you, and there's this method to my madness, so now you're going to see why we did what we did in the warm-up with the marker boards, okay? In a unit circle, watch this. In a unit circle, we're going to see other angles besides the 90, 180, 270, 360. Okay, there's other angles on the unit circle. So what we're going to do is we're going to look at if the hypotenuse is 1, what would these two sides be? And I want you to look at this one up here. Can you see? If x radical 2 is 1, so let's think about that. X radical 2 equals 1. How do you figure out what x is? divide by radical 2. So I'm getting x is 1 over radical 2, but we can't leave a radical in the denominator. So do you remember what we did with the marker boards? You multiply by radical 2 over radical 2, and you guys started getting it without even needing to do it. Isn't that radical 2 over radical 2? So I'm going to end up labeling these two sides, they're equal. But if I force the hypotenuse to be 1, and I'm doing that because I'm working with a unit circle, so the radius is 1, and the hypotenuse is always 1 in a unit circle. So that makes these radical 2 over 2 and radical 2 over 2, because they're equal. So now let's look at the 30/60. But I'm telling you my hypotenuse is 1. Now, you should be able to tell me what the side is across from 30. Jacob, what do you think it is? It's 1/2. And then the one across from 30 is a 1/2 times square root 3. But instead of writing a 1/2 times square root 3, we write it square root 3 over 2. So, I want you to take a moment now and look at that gold paper so that you understand what this is. So I gave you a 45/45, the hypotenuse is 1, and then you have a radical 2 over 2, radical 2 over 2. In the 30/60, the hypotenuse is 1, across from 30 is a 1/2, and across from 60 is radical 3 over 2. That's where these numbers are coming from. All right, when you're ready, flip the page, and now we're going to see, so what? Like, why are we doing this? What is the point? So what we're going to learn is how you find the cosine theta and sine theta of any angle theta that's on the unit circle. So I'm going to take you through these steps, and you do need to memorize the steps. But I think when we do enough of them, you'll have it down. So if I have theta is 60 degrees, I'm doing letter A. So I'm going to watch these. It says sketch the angle. So you're going to draw an arrow here. Here's 60 degrees. Right? That's a 60-degree angle, and I'm going to drop a perpendicular. So you're always going to practice. You draw the angle, drop a perpendicular. Sometimes it's going to come up from the bottom, though, too. And what's really going to be tricky is figuring out this angle down here. Like this one's easy. It's 60 degrees to the x-axis. So if this is 1, 30 is up here. Now look at the gold paper. You want to practice this. Okay, the hypotenuse is 1. Across from the 30 is going to be the 1/2. And across from the 60 is the radical 3 over 2. Does that make sense? All right, so now watch this. Now, when they get into other quadrants, we have to pay attention to, if I go down, that down value is actually negative. And when I go left, that left value is negative. But here, everything's positive. So now, the cosine of 60 degrees. You can use SOHCAHTOA. Cosine of 60 is adjacent over hypotenuse. So 1/2 over 1 is just 1/2. The sine of 60, SOHCAHTOA, opposite over hypotenuse. Now, since it's always over 1, you know it's going to be like opposite or adjacent, right? If it's always over 1, then that's going to be radical 3 over 2. All right, so that one was simple. Okay, that one was very, very simple. So now they're going to get more challenging as we go. The hardest part is step 1 and step 2. Sketching the angle and determining how many degrees the terminal side is from the x-axis. That's going to be the tricky part. So 225 degrees. Anybody remember where 225 is one we saw a lot yesterday? It's third quadrant and it's exactly halfway, right? It's exactly halfway. So what that means, that's a 45-degree angle if it's halfway. And watch what I'm going to do. I'm going to drop a perpendicular, and this is a 45, 45 right triangle. Okay, this is going to get a little tricky, but we're going to spend today and tomorrow on it. So don't worry. I'm going to go nice and slowly so we pick it up. The radius is 1. The sides are radical 2 over 2, radical 2 over 2. And you have it on your golden paper. But what I mentioned on the last one we didn't see, you notice I'm going left. That makes this a negative x value. Going down makes that a negative x value. So the cosine, even though I'm using 25 degrees, because I'm putting it third quadrant, this is really going to be theta's 225. So you always use the original angle in your answer. Cosine 225 is adjacent over hypotenuse. Well, that's negative radical 2 over 2. The sine of 225 degrees is negative radical 2 over 2. All right, questions? All right, let's look at letter C. Let me give you a head start on this one. Sketch negative 45 degrees. See how far away from the x-axis it is, and see if you can draw the triangle. Let me give you that head start. And if you feel confident, keep going. All right, negative 45 degrees is a clockwise rotation. So it's going down here in the fourth quadrant. I'm going to drop the perpendicular, so it's a 45, 45. This is 1, radical 2 over 2, radical 2 over 2. Stop and think. I went to the right, so that's positive, but going down is negative. Okay, right and up are positive, left and down are negative. So now, the cosine of negative 45 degrees, SOHCAHTOA, adjacent is positive, radical 2 over 2. The sine of negative 45 degrees is negative, radical 2 over 2. All right, let's try one more, then I'll pass out the homework and you can start that or work on your Math Excel. You'll have a few minutes. Letter D, theta, 150 degrees. So sketch the angle. So you're never using a number bigger than 90 that's within a quadrant, not on one of the axes. But if it's like second, third, or fourth quadrant in the quadrant, you don't use those big angles. You're either going to use 30, 45, or 60. All right, so 150, how many degrees away from the x-axis is 150? What would this little angle be right here? 30, right? So that's how you figure out what goes in the corner. It's how far is that away. So that's 30. That makes this one 60. Across from the 30 is the 1/2. Across from 60 is radical 3 over 2. Do I have anything that would be negative here? The radical 3 over 2 is left, so that's going to be negative. So the cosine of 150 degrees, SOHCAHTOA, is adjacent. So it's negative radical 3 over 2. The sine of 150 is opposite over hypotenuse. But because the hypotenuse is 1 in a unit circle, it's always going to be just opposite. You can almost like save yourself a little bit of time there.